This lesson is on factoring using synthetic division. The first thing I want to remind you of is that when we solved by factoring, which we'll be doing again, we had factors that look just like they do when we factor, say, with perfect squares or trinomial factoring or anything like that, and we had them set equal to 0. And what we did from there was set each piece equal to 0 and then solve these little equations. And you ended up with answers that had the opposite signs of what they had inside the factor. And so when they look like this with the parenthesis and the x plus or the x minus, we call those the factors. And when we have the answers, when we solve, we call those the zeros, because those are where our graphs cross the x-axis. But we're not going to get into that right now. I just want you to think of these as factors and these as zeros. So we have a rule that we want to look at that says if we divide a polynomial by a certain number, I'm calling a here, and the remainder is 0, then we know that x minus a is a factor of the polynomial. And again, notice the sign difference. Here I'm talking about a positive a. In a factor, it would be a minus a, and the factor has the x with it. So for example, if I wanted to determine if x plus 1 is a factor of this polynomial, and if it is, I want to factor completely. So I'm going to do synthetic division with the negative 1, which is the 0, and I want to make sure that I include the 0x squared because it is skipped over here. So negative 1 will go in the box. I'll have 1 for the x cubed, 0 for the x squared, negative 13 for the x, and negative 12 for the plain number. So I'll bring down the first one, I get a 1, and then do 1 times negative 1 to get negative 1, add 0 and negative 1, get negative 1, multiply, get a positive 1, add and get a negative 12, multiply and get a positive 12, and then when I add the negative 12 and positive 12, I get a 0. Now that is really the important part today because that last number is our remainder. And our rule says if our remainder is 0, then what we started with was a factor. So the x plus 1 is a factor if I get a remainder of 0, and I did. So I can say yes to that. Then they tell us to factor completely. So we have to look at the answer we got here and turn it back into a polynomial. Remember, you start one power less than the problem, so this will be x squared minus 1x minus 12. And then I want to factor that in whatever way is necessary. And in this case, that's a trinomial, so I'm going with x factor. So we get a negative 12 up top, a negative 1 down the bottom, and you're figuring out what can multiply to give you the negative 12 and add to give you the negative 1. So that will be a negative 4 and a positive 3. When I put those in parentheses, those will be how this part factors. But what you have to remember is that this was part of that original. So I need to also include that one x plus 1 that we determined was a factor when we got the remainder of 0. So our final answer would be the x minus 4, the x plus 3, and the original x plus 1. All right, another one. We want to determine if x minus 2 is a factor of this polynomial, and if so, factor it completely. So again, I want to do synthetic division and decide if I have a remainder of 0 or not. So I start with my number in the box to be the opposite sign, so I'll use a positive 2. And then my coefficients are 6, 8, negative 34, and negative 12. And then I'll complete my synthetic division. So bring down the 6 and multiply, get 12. Add 8 and 12 and get 20. Multiply and get 40. Add with negative 34 and get 6, and then 6 times 2 is 12, negative 12, and positive 12 is 0. So again, because I got a remainder of 0, I can say that x minus 2 is a factor of this polynomial. Since it is, I'm going to take my answer and try to factor that. So the first thing I notice is that I have a GCF because at least 2 will go into everything. And then I have the 3x squared plus 10x plus 3. I want to go into my x factor. So I'm doing 3 times 3 to get 9, and the bottom number is 10. So what multiplies to give us 9 and adds to give us 10 is 9 and 1. That gives me x plus 9 and x plus 1, but I want to remember to divide by 3 because that front number was 3. Now that will reduce here It won't reduce here, so I'll bring the 3 to the front. So these are the two pieces I'm getting from this factorization, but I also include that x minus 2 from the original as part of my answer. So my full answer is all 3 of these parentheses. All right, here's another example. If you would like to try this one, hit pause and try this one. So here we want to determine if x minus 5 is a factor of f of x is 4x cubed minus 15x squared minus 30x plus 25. So again, start with the synthetic division. A positive 5 goes in the box, and my coefficients are written down. I didn't have any holes to fill in. When I complete my synthetic division, I get a 4, a 5, a negative 5, and a 0. And because that remainder is 0, this is a factor. Now, this is a good time to tell you that if you were ever to not get a 0, then the binomial you were asked about would not be a factor, and then you would just stop. You wouldn't be able to do anything else. So that's why I haven't done really any of those, is because it's more interesting when it is a factor and you get that 0 remainder. So this one, we got a 0 remainder. We said yes. And then I want to take those coefficients, start one power less in the problem. So I'll start with x squared. So 4x squared plus 5x minus 5. And then I'm going to try to factor. And since this is a trinomial and it doesn't have a GCF, I'm going to go with the x factor. So I'm thinking, what can multiply to give me a negative 20 and add to give me 5? Well, if you think about that for a minute, the things I can multiply to get 20 would be 2 and 10, which I can't combine in any form or fashion to get 5. And 4 and 5, which again are not going to combine to give me 5. So this does not factor any further, but when I put it with the x minus 5 from the beginning, this is the factored form of the particular polynomial f of x named here. So this would be a complete answer. All right, now what you need to remember, and this is where everybody gets mixed up, if they give you a factor like they have in the first few problems, you want to change the sign to put it in the box. Now, sometimes they're going to give you a 0. If they give you a 0, the sign has already been changed, so you don't need to change the sign when you put it in the box. Please write this down. It's incredibly important to keep you from mixing those two things up. So for example 4, we're going to be told that negative 2 is a 0 of this, which means it does work. That also tells me that there should be a remainder of 0 when I do synthetic division. So I'm going to take my polynomial and do synthetic division. I also want you to notice I'm missing that plain number on the end, the constant number on the end. I need to put a 0 in for that. So when I write down, I'm going to use the negative 2 that they gave me without changing the sign, my coefficients 1, negative 2, negative 5, and 6, and then a 0 as the placeholder for that last piece plain number that this one does not have. So I'm going to complete my synthetic division, bring down the 1, multiply and add, and repeat that until I get to the end. Even though I got a 0 here, I do want to keep going, and that last piece should be a 0 because they told me this should work. Then if you notice, the problem was x to the 4th, so this will begin with x cubed. So this is x cubed minus 4x squared plus 3x, and then everything else was zeros. And then if we're factoring completely, I want to continue to try to factor here. It is a trinomial, but I have a GCF, so I can take out an x. That leaves me with x squared minus 4x plus 3, which I can do with x factor. So I'm multiplying to get 3 and adding to get negative 4. That will be a negative 3 and a negative 1. I still have the x out front. I have the x minus 3, the x minus 1, and then that last piece for factored completely is the factor that gave us the 0 of negative 2. So I need to reverse the sign when I come back into the factor. And that is the end of this lesson. If you will complete the practice problems that are assigned to you.